Ever try to get something done, but your computer is just too slow to handle everything you've got? I mean, come on, I've got deadlines. Well, quantum physics is here to save the day with the magic of magnetic RAM, or MRAM for short. How does it work? Well, let me teach you. But first, what even is RAM? RAM stands for Random Access Memory, and it's basically the short-term memory of your computer, and it allows you to do multiple tasks at once. Say you want to browse the web, watch a video, or play a game all at once, well, the better the RAM you have, the better you can do this. Traditional RAM, like dynamic RAM or DRAM, stores information in tiny capacitors by manipulating the charge stored in them. You can think of capacitors like a cup. When there's no charge stored in it, well, that represents a 0. But when you do have charge stored in it, that represents a 1. However, capacitors often leak charge over time, causing the stored data to be lost if it's not constantly refreshed. But to constantly refresh, you need constant power, which is not energy efficient. Also, traditional RAM is volatile, meaning that the second you turn off the power from your computer, all the data you had stored is lost, gone, poof. Well, magnetic RAM, or MRAM, is here to combat this. Instead of relying on electric charge to store data, MRAM uses magnetization and the electron spin. The key to MRAM is a tiny structure called a magnetic tunnel junction, or MTJ for short. Now I know all these terms sound very confusing at first, but Professor Einstein is here to explain it to you. Let me break it down. This MTJ consists of two magnetic layers separated by a thin insulating barrier. One of these magnetic layers has a fixed magnetic orientation, while the other one is free to change its orientation. You can think of each of these layers like a bar magnet, which has a north and south pole. For the fixed layer, the bar magnet can only point in one direction, but for the free layer, the bar magnet can flip directions. Now, different types of MRAMs use different mechanisms to change the magnetic orientation of the free layer, but it all boils down to changing the direction of the electron's spin in that layer. Electron spin can be thought of as a tiny magnetic moment, but we'll save that for another video. But what's important to know is that when both of these layers have a magnetic orientation aligned in the same direction, the resistance across them is going to be low, and this will represent a 1. Now, when the two magnetic orientations are unaligned, that's going to be a high resistance across them, representing a 0. Now, if you're curious like me and want to know why this works, we have to go over to the quantum realm, specifically quantum tunneling. Now, whenever the computer wants to access the data stored in our MRAM unit, it sends a small current straight down through the MTJ. Now, if you remember, we have an insulating barrier in the middle of our MTJ, and insulators are supposed to stop the flow of electrons, right? So how does this work? Well, quantum tunneling is the effect where electrons can tunnel straight through an insulative barrier. It's like grabbing a football, throwing it at the wall, and it just goes straight through the wall. It's actually crazy. Now, quantum tunneling doesn't happen 100% of the time. It depends on the orientation of our two magnetic layers. When both of them are aligned in the same direction, the likelihood of tunneling increases. And when they're unaligned, the likelihood decreases. Now, by measuring the amount of electrons that were able to tunnel through our MRAM unit, we can determine if it was either a high resistance or a low resistance, a 0 or a 1. So now we know the basic working mechanisms of MRAM. But you might be wondering why MRAM is even better than traditional RAM. What are the advantages? Well, the biggest is that MRAM is non-volatile, meaning that it can store its data even when the power is shut off. This is because the magnetic orientation of the fixed and free layer does not change. It is not dependent on power. Once the magnetic moments are aligned in one direction, they're going to stay in that direction unless it's changed by some external force. This is huge because we don't have to constantly supply power to store and refresh our data as we had to do with traditional RAM. And there you have it. MRAM powered by quantum physics is here to speed up your computer, making sure you can get your tasks done fast. Now, if only I could quantumly tunnel through my workload.